Welcome everybody, I'm Eric Dresselhaus, CEO of ESS. We're excited to welcome you to our facility here in Wilsonville, Oregon, and tell you a little bit about what we're doing to do our part of facilitating the energy transition. ESS was founded about a decade ago with the mission to provide long-duration energy storage to store wind and solar to help decarbonize the energy system. And when the company started, originally it was looking at a different technology. It was looking at vanadium and quickly determined that that was too expensive and wasn't going to meet the needs of the market. And so after a bunch of research, the founders settled on an iron flow redux battery. And iron flow batteries were exciting for a number of reasons. They were inherently safe, they had long durability, and they had a great cost point when they got to scale. And so I want to take you through the journey of how we got from those early days founding the company to where we are today. So the first battery that the company developed can be seen right here. It's a very small cell prototype battery. The exciting thing about this is it works so well we still use them in the lab today. And it proved back in 2012 that the technology would work and encouraged the company to move on to larger and larger scales. So this original 2012 R&D unit gave birth to what is called the Rev7 battery stack. And as you'll see, this is a very manually built device. The layers of each battery cell, or part of the stack as we call it, were all very manually produced, hand-tied with bolts, hand-wired. But this proved that the unit could scale, in this case, up to 12 kilowatt hours per battery cell with sufficient performance to encourage the company to build a device that would go into field use. That gave birth to the Rev9 battery stack, which as you can see is much cleaner, much easier to produce, and of much higher quality. These units were deployed in the field and really encouraged the company to move on to even greater scales to meet the market demands for long-duration energy storage. With that, we'll take a look at the products that we ship today, which we think of as the second generation of iron flow battery product. All of those early years of research, both in the lab and in the field, gave birth to what we think of as our S200 or second generation battery design. As you can see, this is a much larger footprint than the earlier prototype batteries were. This is a 50 kilowatt hour battery, a welded design, much more manufacturable, much more durable. This is the product that we ship today, and in a little bit we'll see some of these being built out on the factory floor. The learnings here have given birth to a successor product, which is a 100 cell stack of the same design. Much larger, twice as large in fact, with a little bit more energy storage, a little bit more plating material in 100 stacks. That helps us drive cost out and have a much more manufacturable design. So we'll start shipping this product this year, and you'll start to see this show up in battery systems in 2023. Although the battery stacks are likely the first thing people would think about when talking about an energy storage system, the other key innovation ESS brought was a thing we call a proton pump. What you're looking at here was an early proton pump introduced in 2019. What a proton pump does is it keeps the electrolyte in the system balanced, and that allows effectively unlimited cycling of the unit, ensuring that the electrolyte is clean and clear and balanced for operation and storing electricity. Now this unit, as you'll see, is very manually built. It's got a lot of connections. Everything here was handcrafted with nuts and bolts. But the learning and the experience here showed that the proton pump worked. And from this design, we've graduated into a second generation design that you can see right here. A much cleaner design, many fewer connections, everything is welded, and it's a smaller footprint. That's a lower cost, higher reliability unit, which is what we ship in all of our products today. With that, let's take a walk out to the factory floor and we'll show you how we build these products. Innovation's at the heart of what we do here at ESS. Our technology was developed right here in Oregon, and we continue to innovate and expand our capabilities today. We have 175 patents either issued or in process, and every day we go to work to make the product better, more affordable, and longer lasting for our customers. We're here on the factory floor in Wilsonville, where we've recently expanded our manufacturing capabilities from about 18 megawatts to 80 megawatts. I'm standing in front of one of our semi-automated lines, which is how we've built product in the past. Now, I think it's important to recognize that building an iron flow battery is really the convergence of three things: electrochemistry, material science, and precision manufacturing. So this is where the manufacturing comes into play. We start at the very bottom. Every layer you see in a battery stack is a battery. So we take 50 of those today, and we build the battery stack up. And it's really important that those are built with very exacting standards. That's still today a very manual process, which then after the manual work is done, it's handed off to the robots to ensure that the seal between all of the layers is done with great precision. And we've taken all of this learning and all of the stacks that we've built and moved into a next generation fully automated line, which we're gonna go see now. So now we're standing in front of our first fully automated line that we commissioned back in December. And we're really excited to have this up and running. It incorporates all of the learnings we've gathered over the last few years into a much more efficient, much less labor-intensive manufacturing process. All of the bolting, the soldering, the pressure testing are all done in line. This has had a dramatic impact, improving our labor efficiency 3x, ensuring that we get great quality off of the end of the line. At the end of the manufacturing line, we have completed battery stacks. Each of these are put through thermal and pressure testing to ensure quality before they're put into finished systems. And for that, I'll turn it over to Vince Canino, our Chief Operating Officer, to tell you how we do that.
Thanks, Eric. Very excited to be part of the ESS journey. Where we're standing here right now is where the life of an energy warehouse begins. This is what we call the systems integration area. And this is where we build our sub-assemblies for our plumbing, as well as our power electronics that you see right in front of me. As we've been scaling up manufacturing, we've been really working hard to root out the inefficiencies of production processes. And one of the areas we focused keenly on lately has been lean manufacturing and 5S. And so some of the things that you'll see, like the tooling behind me here or the Kanban, is a way that we can eliminate the non-value added time and steps that a technician has to take in order to have them focus more on the value added steps of building the actual components. So another example of how we're improving our design and ensuring better quality is this octopus harness that we have right here. So this not only improves our reliability and the quality of our builds, but it also reduces the amount of labor. In the past, we would take these hundreds of different wires and do a hand-to-hand, point-to-point contact. And now we're able to reduce this into one harness and very quickly connect these up. And we call this affectionately the octopus harness because of all the tentacles that we have here. Power electronics are the brains of any battery. However, in flow batteries, plumbing is very critical as well. And that plumbing starts with these tanks right here. And what we've done at ESS is we've went with a single tank design that has a baffle or a chamber that separates the positive electrolyte from the negative electrolyte. So the electrolyte in the system flows from the bottom of our tanks here through our pumping system and then is delivered to our power modules. From the power modules, it's delivered back to the tank at the top of the tanks. Our power electronics do the charging and discharging. What that means is we have a single directional flow of our electrolyte. This is really important because it provides a rapid response since we don't have to turn pumps off and reverse flow. This gives us the ability to provide ancillary grid services such as frequency response and voltage response. The beginning build of the energy warehouse starts with the installation of the tank, as you see behind me. Once the tank goes in and some of the plumbing, we then install the electrical cabinets where we'll populate it with the power electronics. Lastly, we'll then install the insulation. Unlike other technologies, we don't require air conditioning, even when deployed in a desert. So once all the plumbing and the power electronics are installed, this is where the magic happens. Here we take what we call a quad pod, which is 4 battery modules that we wire up and finish up the plumbing and put them together onto one pod, thus the quad pod. We take 3 of those quad pods and then load them into our energy warehouse, and that's how we get our 75 kW of energy storage. So once the quad pods are loaded into the container here, the next step in the process is to do a functional verification test to make sure that our electrical connections and plumbing connections to the battery stacks are in good working order. These test bays here can do both AC and DC type batteries. From the functional verification test, we then move to an end-of-line test.
So we've come to the end of the manufacturing line, and as you can see, all of the units are going through their final testing before they are sent for shipment to customers. You can see the pumps and the proton pumps are in the back of the units for easy servicing and maintenance. In addition to the units that are prepared for shipment to customer, we have units that stay here at ESS, things we call durability units. Those are used for extended life testing and to help us test out new innovations before we incorporate them for customer shipment. Thank you for coming on the tour of our facility here in Wilsonville, Oregon. We're excited for the growth we've had in 2022, and we look forward to more growth in 2023 and beyond as we work to meet the world's need for long-duration energy storage.